So, and the other major challenge was the procurement cycle. I mean, you have over provisioned your storage or servers, and you need to expand. So there might be a chance that the capex approval, you should have budget, and maybe that even for government sector, it can go up to 6 months. So you have to plan 6 months ahead. And there are so many things which was a huge challenge to run an on-prem cloud or on-prem data center. So what is cloud? We discussed VMware virtualization. So what is a cloud? Cloud is like, it's the virtualization layer, which is the most basic layer, and many orchestration layer on top of it. You have SDN layer, you have and every layer supports multi-tenancy. Whenever some tenant requires a virtual data center, he will get the compute, he will get the storage, he will get the security and availability, disaster recovery, everything, just like he has its own data center, and everything is there in multi-tenancy. So the cloud is nothing but a online data center which is completely isolated for any organization or any person to use. And instead of relying on local servers or personal computer to handle data and applications, cloud computing utilizes network of remote servers hosted on internet. But okay, let's first see the benefits of cloud. It's very cost effective, but this is a relevant term if your workload starts increasing, if your if your workload starts increasing, you are using so many compute cycles, you are using more RAM, more high performance disk, maybe the cost is not so cheap. And it depends. For individuals, cloud is the way to go. The scalability and elasticity. Of course, the cloud, they have invested hundreds of billions on their data centers. So they have huge compute, storage, RAM available. So you can scale out very easily. And elasticity is the beauty of cloud, depends on if even if it's a on-prem cloud or it's a public cloud. Flexibility and accessibility. Of course, if you are running your workload on cloud, you can access your cloud from any part of the world, and it is, it is always available because they have invested so much on the cloud. So they make sure that their cloud is reliable and available. Otherwise, they will lose the business and the trust. Data security and compliance. So when you're shifting to the cloud, they are hosting someone else's data. And if the data breach happens, there will be a huge impact on their business. So they do huge investment on security and compliance, and they are certified by many organizations. Because if the data is not secure on the cloud, nobody will use the cloud. And they have teams of pen testers, they have, the penetration testers, they have the teams for compliance, and they have dedicated teams and experts from, every they think of every dimension. They might have ethical hackers and pen testers. So they invest huge on their data security. Plus environment sustainability. If everybody is running their own small cloud, every organization is running their own small data center, they need to have a genset, they need to have a power system, they must have a cooling system. So might be the efficiency of a small data center is not as good as what the cloud provider is managing. The And it will help in environment sustainability because it will have lower carbon footprint, it has lower effect on our environment. And rapid deployment and time to the market. What is rapid deployment? Before cloud, if we need to run a workload, if we need to have our own data center, maybe you need at least 6 months to 1 year to set up your data center before taking your application to the market. Or maybe if you want to have a new application, but that new application requires a new hardware, maybe your procurement cycle is 3 to 6 months. So the time to market is delayed. On the cloud, you just go on AWS, GCP, Azure, whatever your choice is, you go in, click on your machine, and you're ready to go. And the disaster recovery, you don't need to think of it. You just can have with the push of a button, you can initiate your disaster recovery. You can take the backups, you can take you can think of so many options when you are going to cloud, which you cannot do on-prem. The service model, you will hear these terms a lot. infrastructure as a service, platform as a service, and software as a service. Okay, infrastructure as a service. What does that mean? Or IaaS. We are just running a VM with operating. Actually, I can define infrastructure as like you have physical data center available. On top of that data center, you have everything. The cloud is installed. The virtualization stack is installed. The cloud is installed, and the company will or the cloud will provide you just a VM with operating system. You don't need to manage the below infrastructure, the virtualization and everything. So you will have the virtual machine, and you will install whatever you want to install on that virtual machine, and you will manage it yourself. So that's called infrastructure as a service, because you are using just the infrastructure. You are doing everything by yourself. Now the platform as a service. You are a developer. You don't know how, or you don't need to know how to install a virtual machine, or how to set up a Linux environment to run your application code, your PHP code, because you are just trying to write some small function and test its functionality. Even if you are doing it on your laptop, first you have to install a web server. Maybe you should have a Visual Studio Code. Maybe you need a license for that. So why not, if there is a platform already available, you just go there, put your code there, and it tells you how your code behaves. Or the platform can run the code for you. Just like Microsoft Azure App Service, Google App Engine. You don't care if your code is in .NET. You just throw your code, and it will run your code. It will execute your code. So that's the platform. Like the VM, there might be a software on top of VM, or you are using that platform as a service. The third thing is software as a service. Everything is managed by someone else, and you are just using that software. Like your email, it's software as a service. You are not writing the code. You're not managing the servers. You just go in there, log in there, send the email, receive the email, and that's it. So that email software is managed by someone else. We are using this Zoom. We are just putting our credentials. We don't know how our video is recorded. It's stored where. We are talking with each other. So this software we are using as a service. And plus it supports multi-tenancy. You can have Google Workspace. So every software hosted online and support multi-tenancy, that's called software as a service. So I have a diagram available. So this dark blue is you manage it by yourself. When you are on premises, everything, networking, storage, servers, virtualization, OS, middleware, runtime, data applications, you do everything. If you're going infrastructure as a service, so the networking, storage, servers, and virtualization is managed by your service provider, and you are taking care of just the OS, and you can see the diagram. So in platform as a service, your service provider, all the layers except your data and your applications. And in a software as a service, they have it all. They are responsible for the disaster recovery. They are responsible your data backup, the security, the compliance, the integrity. Every tool they will deploy, we are just using the service, and this is called software as a service. This is the most easy to use service. So now you might be thinking, cloud computing, if someone has invested so much on their data center and they have all the compute available, so why should they go to cloud? And what's the model for them? So we will discuss that in this slide. So we all know what public cloud is. It's like AWS, Azure, GCP. There is a concept of private cloud, which is on premises, but it is a cloud. And there is a concept of hosted private cloud. These are two different concepts: on-prem cloud or hosted private cloud. And then there is a concept of hybrid cloud. Maybe there is a company or even a government, they are not, their compliance don't allow them to go on a public cloud. So they should have, and they want to use cloud. So we will discuss that in detail. So cloud computing models, public cloud, everybody know all services are online. The storage is online, the compute is online, everything is online. So this is a public cloud. So nothing new in that. So in private cloud, we have two options: on-prem or hosted private cloud. What's a private cloud? On-prem. You have complete infrastructure ownership. You have complete control and customization, but you have to spend huge capex on that. And you have challenges of resource scalability, I told you before. You should have maintenance and support SLAs with all of your OEM who are providing you hardware, software, the cloud. Of course, you will have some cloud solution. Maybe you are hosting VMware cloud. Even you can have Huawei cloud. You can have Azure cloud. They all have their on-prem cloud versions, which are limited in scope because they are not providing to general public. And every or add-on charge, every add-on in your cloud will charge you a license cost. So this is the most expensive cloud to manage. But the government organization, the secure, it may be some agencies which do not want their data to go out of their agency or their premises, so they can invest on private cloud, and you have solutions available for them as well. Then there is a concept of hosted cloud. Like, I cannot go on a public cloud, but maybe my country's regulation allow me that I should be hosting in, let's say there can be a data center which is very huge and it is managed by some government organization, and that organization has all the system, storage, compute, networking, the data center available in the same country, and they have invested a huge amount on it. So I am allowed to take infrastructure from that facility, and the infrastructure ownership is there. I am just utilizing it. They are providing me the managed services, and we don't need to put capex or a huge capital expenditure. The initial investment is not required. It's an operational model, opex model. So we will be paying them the rent, and we will be using their infrastructure. It has better scalability and elasticity compared to the on-prem cloud, because the organization has a limited budget. But if some company has built a cloud to sell, of course they have, this is their core business, so they must have invested more than you. So the scalability and elasticity is better in hosted private cloud. And we only have SLA with that company where we are hosting our data. And that company must have many SLAs with their vendors, with their service providers and everything. So you have just one window, one service provider who is providing you the services, and you just need one service level agreement with them. There is a concept of hybrid cloud. I mean, we used to, when the cloud was pretty new, so everyone has no confidence over the cloud services. So people were, there were some just web servers that are used by the company, and then there are databases and some critical load. So in the time of load, the non-critical services were moved to cloud on the fly. So you have your own investment already there. When your load crosses particular limit, you can spin the services on the cloud, and when your load is gone, you can just shut them down. You have your capex there, so you don't need to pay a lot to hybrid cloud, and you don't need to sorry, public cloud, and you can save some money there because you have already invested on your data center. So combining public and private cloud infrastructure is called hybrid cloud, but it has so many challenges. It is very complex because you might be running VMware on the cloud. There should be a platform which supports VMware VMs. So the interoperability is so much important. Data integration, security compliance, if the data breach is from your premises or from the cloud premises. So the that will be too tricky in case of hybrid cloud. Data governance and control, network connectivity and latency. Of course, if your data center and the public cloud data center, if there is latency in it, your services will suffer. Moving to and fro things, it will suffer. Maybe your application in the cloud is connecting to the backend database which you are running on premises. So if there is latency, your application will take the hit for that. Plus, if you are, let's say, if you are managing public and private cloud and you are selling the services further to someone, then the cost management of both on-prem and cloud needs to be very clear and managed, and you have to take care of both the prices while providing services if to some third party. And again, you should have a deep knowledge of your cloud and your public cloud, so that if there is anything wrong, both teams can coordinate with each other, and they should have deep knowledge of both the infrastructure, which is very difficult. So maintaining this kind of skills and training is very expensive and always not available. I think that's it with the cloud. I mean, my throat is dry. Amazon Web Services. So why AWS? I was telling you it is very flexible in terms of pricing. Every cloud gives you pay as you go model. What is pay as you go? You can go with one CPU, 1 gigs of RAM, probably 10, 20, 30 gigs of hard disk. And if your services start growing, you need 2 CPU. You can increase the CPU to 2 and you will be charged for 2 CPUs just when you increase your CPUs. So you pay when you use it. So you will start consuming more and more CPU. You don't need to invest on your CPU from day one. So the pay as you go is the selling point of a cloud. Actually, they tell you that if when we are planning in our on-prem data center, we normally plan for 3 to 5 years. So we have to invest a huge amount for the CPUs. We don't need initially. Maybe we will use them after 3 years, but we are buying them ahead, 3 years ahead. So that's wastage of money. So in the cloud, it is pay as you go. You can just start increasing. You can start with the minimum, and if your load is growing, you can grow with the load. Time-based usage. If your VM is up, you are paying them. If your VM is down, you are only paying them for the hard disk, not for CPU, not for RAM. And in that time, that CPU or RAM is utilized by some other person. So it makes win-win for both the user and the cloud provider. Scaling up and down in cloud is so much easy. You can just the huge infrastructure is available. You can scale up, I mean, a lot, and you can scale down to your minimum if you don't need to pay a higher cost. Then I told you before, they invest so much in security and compliance, and they are providing you it as a service, and you don't need to manage the firewalls and the rules and everything. So everything is managed on software layer. Again, huge infrastructure and global architecture. So AWS, I believe, it has the maximum uh, footprint globally other than any cloud. And after that, I guess it's Azure and then Google Cloud. So in AWS, we have regions and we have availability zones. So available region is what? They have locations globally available, which are they have divided into regions. One region is serving specific area, but it doesn't matter that nobody else from any other region cannot take services from a particular region. And region wise, the prices also vary. The availability zones are the data centers in that particular region. So there is a region, and region can have 10, 20, 30, 40 data centers, and that are called availability zones. So this is AWS Global Infrastructure Map. They have 99 availability zones with 31 geographic regions around the world. And the greens they are already there, I mean, from across China to Canada. They have from Dubai to, I mean, of course, USA is there. I'm talking outside USA. And I believe in India also. So they have a huge presence. And they are now, the coming soons are what? Canada, Israel, Malaysia, New Zealand, and Thailand. So they will be up in no time. So now we are coming to the most important part, domains of AWS. What AWS is offering. I mean, I am telling you a very small section of it. The services are so huge that I mean, they have catered it for everyone, for the developers, for the media industry, for the streaming. I mean, for everyone. I cannot know it all. I am just telling you the EC2, which is what is EC2? Amazon Elastic Cloud Compute. So cloud and compute, two C's are coming. So this is why it's called EC2, which is actually a virtual machine. That's it. Then we have Elastic Beanstalk. I don't really go into there. And they have a service migration from physical to AWS. Like if you're running some workload on your physical infrastructure and you want to migrate to AWS cloud and of course, then you will be running on a virtual machine. So every cloud platform offers you this service. It's called P2V migration. The migrations are from V to V, virtual to virtual, and they are from physical to virtual. And I mean, you can go from virtual to physical, but I have not faced any such scenario. Like you are going from cloud to on-prem. I mean, you can do it. There are tools available, and no big deal. So security and compliance, IAM, identity and access management tools. They give you storage of many types, the block storage, the file storage. I mean, that's an complete domain. Storage is another domain. They give you the networking, VPC. VPC is virtual private cloud. It is your tenant isolation boundary. Your machine is isolated inside a VPC. It is actually your data center. It's your virtual data center in Amazon's huge data center. You use the overlay networking in overlay, software defined networking in virtual private cloud. Then you have direct connect. You can connect to a leased line. Let's say I don't want to go over VPN, then I should have a leased line which is dedicated for me. So I can directly connect to that leased line. And Route 53 is the DNS of AWS. They have messaging platform available. They have databases, SQL databases, NoSQL databases, and they have management tools, monitoring tools like CloudWatch, and so many more. Elastic, we all know it means we can increase or decrease the resources. So now while selecting your EC2 instance, you should take care of so many things, like your application is a general purpose application, or your application is a RAM hungry application, or your application is a CPU hungry application, or you have a lot of data, or you need to render something. I mean, you have to know your application to select the right instance of your choice. Then it will be beneficial to you in terms of cost and in terms of performance. Like if I am running a small website, a general purpose instance is enough for me. But if I am doing some data analytics, I need a lot of CPU cycle. So I can go with compute optimized instance or virtual machine. If I am running some application who is taking huge memory, I can go for memory optimized instance. And then we have accelerated component. They have hardware accelerators in their machines. I mean, they have whatever they are providing you, they have a backend infrastructure on it, and they have investment on that infrastructure. Let's say if you need to render something, you need GPUs. So physical GPU cards must be installed in that hardware. So if you are rendering something, so you will select your GPU optimized instance. So that instance will only be created on the hardware which supports hardware GPU. So HPC is high performance compute optimized. And there is another option of cluster networking. You can mix and match T2, you can have T2, T3 compute optimized, and you can put all of them in a cluster. And I think they will provide 5 gigs of connectivity speed between the two VMs, and it can go up to, I don't know. So to save your cost, you can have multiple types and put in your cluster networking. So while running an instance, you should know the exact requirement of your application. And if you don't know the requirement, it is always a better idea to just go for a general purpose T2, T3 instance. And again, as I was telling you, the pricing model also depends on your requirement. So they have on-demand services. AWS can provide you dedicated, physically isolated hosting. They can provide you Spot hosting, and let's say what is on-demand. You lease it for some time, and after that time, it is terminated. I mean, if I mean, it's self-explanatory, but it's available on demand. Then you have dedicated, which is I think the most expensive hosting of AWS, because they provide you physically dedicated and isolated servers. Maybe there is an organization, their compliance says that you cannot share even the operating system or the physical hardware with anyone else. So even they can have services from AWS. So that's called a dedicated hosting. Amazon has some Spot instance. I have not used them, but Amazon EC2 Spot instance let you take advantage of unused EC2 capacity in AWS cloud and are available at a discount of up to 90% compared to on-demand prices. But on these Spot instance, I think you have to bid for the VM because the resources are available, but they are not guaranteed. Reserved is like you have reserved your hard disk or your resources and you are paying for it. So you should be reading the terms and conditions of all these models. All these models are available and you have to pick which is actually suitable for you. And you can have on-demand capacity reservations also. Let's say I have a 50 terabytes of data. I may be thinking that I can have 20 terabyte more. So I can reserve that 20 terabyte more because whenever there is a need, if that 20 terabyte is not available because the cloud in that cloud is you are running on some region in some availability zone, there is a chance that the resources on storage exhausts there. And so if you don't want to take that risk, you can do the capacity reservations, you can pay for it and you can have it when there is a demand. So again, instance types, we have burstable instance, which are the T instance. Like we know our website can take almost 20% of the CPU all day, but in between there are times it can go on 80 to 90%. So burstable instance are they are the most economical instances of they are the T instances. You paid them for the baseline, and if the bursts are for a very small time, Amazon will not charge you. And if it is continuously using the 100% CPU utilization, maybe then you have to increase the CPU or you have to optimize your application. And you need to read the terms and conditions if you are using it for how many long time that they will charge you, but they will charge you very economically nominally. So burstable instances are the general purpose instance. Then EBS optimized, elastic block storage optimized, processing data at high speed. And if you need to a lot of IOPS, you can have NVMe SSDs. You can have, so we will log in into the portal and we can see how many storages are available for us. And cluster networking. Thank you for bearing with me for almost 1 hour.